First, let's take a look at this inaccessible button with modal component. It has a local state and renders this button as a div. And this is totally inaccessible. For example, if I press tab, I can't focus on the button. I can only interact with it by clicking with the pointer. And even though I'm able to close the modal by pressing escape, because the modal itself is accessible, the focus doesn't go back to the button. And even if it did, I wouldn't be able to activate it with the enter or space keys as it's expected in a button. So let's imagine we have a React custom hook called useButton that returns props that we could pass to our component. Or we could have a button component where instead of passing children directly as an element, we would pass children as a function. And this function would receive the accessible button props. Then we could pass those props to our inaccessible component. Or finally, more easily, what if we could just pass our inaccessible component to the as prop in the accessible button component, and the button component itself would be responsible for injecting accessible props into the inaccessible button with modal component. Well, in all these cases, I expect that the useButton hook and the button component, either with the render props or the as prop, would fix the accessibility issues of our inaccessible button with modal component. So here, for example, I could move focus onto the button by pressing tab and activate it with enter. The moment I close the modal, the focus moves back to the button. So my name is Diego Haas. You can find me on Twitter or GitHub at Diego Haas. I'm the author of Reakit, which is an open source library that helps you build accessible components for your React app. It provides very handy composition APIs, and I'm going to talk about some of them here. And after almost 2 years working with these APIs, both internally and in the library and as a user in other projects, I've learned the pros and cons of each of these APIs, and I'd like to share them with you here. Also, I'm a JavaScript engineer at Automatic, which is the company behind WordPress.com, WooCommerce, Tumblr, and several other projects. We do a lot of challenging open source JavaScript and React projects. And in my whole career, this is the only company that I really recommend people applying. So I really recommend you to take a look at our site, automatic.com. The first thing I want to talk about is something I call the open-close component, which is based in one of the solid principles, the open-close principle, which states that an entity should be open for extension but closed for modification. In practice, when we apply this into React components, it means that we can easily extend the functionality of a component without having to touch its own code. So let's take a look again at our inaccessible button with modal component. I've also added a class name and style props here to make the explanation more complete. And the first thing we have to do here is choosing an element that will be the main element of our component. In this case, it's the button. So we have to receive props in our component and spread them into this button. Also, we have to enable the style to be customized from outside without having to modify the internals. So we'll merge the class name and the style props. We also have to merge the event props, so we can also add events from outside, and also forward the ref prop. If the component is already using a ref internally, we would also have to merge the refs. Well, it may look a bit complicated, but this is exactly what you get from styled components, for example. The component you create with styled components is itself an open-close component, and this could be used here as well. And these are the modifications we need to make to our component to make it open for extension. And now we can inject other props into it to enhance its functionality, or in our case, to fix an accessibility issue. Now I'm going to talk about 3 different patterns we can use to provide props for this component. The first one is what I call component hooks. So here, for example, we have a very simple component. To turn it into a component hook, the first thing we have to do is renaming the component to useButton. Then instead of returning a button element, we'll return an object with the props that could be passed over to a button element later. And since we want to make it accessible by default, no matter which element these props get passed to, we add other props to guarantee that the final element will be accessible. And this is our hook. And why is this a hook? Why is this named useButton and not just something like getButtonProps? Since it doesn't use any other hook inside, it doesn't need to be a hook, right? Well, that's the same reason we create a button component and not just a render button function. The fact that the button has internal hooks or not is just an implementation detail, and that's why I call it a component hook. So how do we use it? Well, we call the hook, it's going to return props. We can pass those props to a div, to a button element, or to our inaccessible button with model component. And since we've also written this component hook following the open-close patterns, we can also combine it with other component hooks, like this use tooltip reference to make our button also a reference for a tooltip. So the tooltip will appear next to it. We've been using this technique to build Reakit components internally, and all the components in Reakit are made up of component hooks, and this is what I've learned about this so far. So what's the pros of this approach? The first one is the rect element tree. By combining only components, we'll get a bigger element tree, whereas with component hooks, we would have only one item, which is the component that is using the component hook. But you still have the ability to inspect the component hooks that are being used through React DevTools. And besides helping with the element tree visualization, this also gives you a little performance benefit because with fewer components, React will also have less work to do. But this is more of curiosity than information that you should rely on to make your decisions, because it depends a lot on the complexity of your components or how many components you are rendering. Most of the time, although it's something good, the benefit is very small. Well, and now we have the cons of this approach. So the first one is the rules of hooks. So unlike components, we can't use hooks within conditions or dynamic loops. And because by design, we can only return props and not components, we can't make use of rect context or rect portal because they need components. And also, we can't use things like styled components in our component hooks. So if you're creating component hooks to abstract styles, you will only be able to use class name and style props. The second technique is render props. So taking this simple button component as an example again, we can take advantage of the use button hook we just created, since it already implements all the accessible button logic that we need. Then we'll verify if the children prop is a function. If it's the function, instead of returning the element, we'll just call the children function passing the props as the argument. So how do we use this? Instead of passing a children element directly, we pass a function that receives props, which we can pass over to other components, like our inaccessible button with model component. And the same way as component hooks, if we use the open-close patterns in the components that implement render props, we can also combine them with other components with render props, like the tooltip reference, and this will work the same way as the component hooks. So what are the pros? Well, it's a component. It's not subject to the rules of hooks. We can also render components like React portal and context. Since we also expect to receive an element as a result of calling the children function, we can simply wrap this element with other component. What are the cons? So comparing to component hooks, we'll get a bigger element tree. And another problem is that if you have to deal with performance issues, it's harder to do it with render props. For example, this state collocation strategy is a very effective and simple way to solve many performance issues. To give an example, we have local state in this app component, and when this state is updated, the app component will re-render together with all the elements that it renders, like the wrapper and the child elements. And if the render of these multiple child elements is causing performance issues, a simple way to fix it is by abstracting the local state into a separate component that receives children. At this point, when the local state is updated, React will only re-render the component where the local state is defined, which is the stateful component, and not the app component. It's not going to propagate the update to the components up in the tree. And since the child elements are defined in the app component, they wouldn't be re-rendered. But let's imagine that at some point requirements change, and now the child element expects to receive a prop that depends on that local state, which is not defined there anymore. One thing that you can do is using render props to lift the state up, but even though it still looks like the child elements are still being rendered or still being defined in the app component, actually the thing that is being defined here is only an anonymous function that receives a value. This function will be actually called in the stateful component, which will be responsible for rendering the child elements. For React, it would be the same as rendering the child element directly there. So at this point, we lose our state collocation optimization. Well, another way to solve that is by using React Memo. So instead of state collocation, we could simply use React Memo, and then React would compare the previous props with the next props, and it would only re-render the child component if the props are different. Then the child elements wouldn't be re-rendered every time the local state is updated, but only when this selected prop is modified to true or false. But what if the child component also implemented render props? Render props are usually passed as inline functions, which are recreated on every render. So whenever the local state gets updated, the app component will be re-rendered and a new children function will be defined. This children prop will be different from the previous children prop, and React Memo will be always invalidated. And then we have the last technique that I want to talk about, which is component injection, or the sprop, which is how it's usually implemented. So to implement this, we can use the same component that we have been using for the render props. We'll accept an sprop, which we rename to a capitalized name so we can use it in JSX. And then we verify. If this sprop has been passed, then we render that component passing the other props to it. And now we have a single component that makes a use of component hooks and provides render props and component injection APIs. So how do we use it? We'll simply pass another component that must follow the open-close patterns to this sprop. And this can be our accessible button with modal component or a styled component, for example. And what are the pros? So like render props, it's a component, so we are free to render it dynamically or use other components internally. And other advantage is that this approach solves our problem with React Memo and render props. So taking our render props example, instead of passing children as a function, we'll just pass a prop that is constant, since our accessible button with modal component is a function that is declared outside of the scope of this component. So the time React Memo runs its comparison, the sprop will be always the same as the previous prop. And this is actually so powerful that even though our inaccessible button with modal component doesn't use React Memo, you will get the benefit of React Memo. And it's going to update normally when it's local state updates, because local state and context bypass React Memo. Another advantage is that with component injection, we have a much cleaner and reasonable code comparing to render props. So I think we can conclude with that component injection is the best of the approaches, right? Yeah, well, the same way it can be less verbose, it can also be more verbose depending on what you are trying to do. For example, with the render props, you can easily pass props to another prop instead of just spreading them onto the component. With component injection, though, you can't easily do this. You can't pass an inline function to the S prop because this prop expects to receive a component that will be passed over to React create element. In this case, you would be passing a different component on every render, and React would not update but mount a new component on every render, which is definitely not what you want. So in order to achieve this with the S prop, you have to create this intermediate component. And things get even more complicated if you take TypeScript into account. It could be a whole talk only talking about the S prop and TypeScript. So you can access this URL, bit.ly/TypeScript-s-prop, where you will find a boilerplate on how to do that. But even so, this is far from ideal. But the biggest problem that I see with component injection is the prop name collision. So for example, we have our button component, which receives an S prop, and our inaccessible button with modal component, which receives a custom label prop, whose implementation renders a visible label on the page. And then the way we combine these components is by using button, passing the other component to the S prop, and also the label prop. And since button passes down all the props that it doesn't use, the inaccessible button with modal components would receive this label prop and render as a children in the div. But let's go back to our button component. What if at some point we add a new feature to this component, and now it's going to receive a label prop and render it as an aria label attribute in the HTML, which is not visible on the page. So since it's a custom prop and button uses that, it's not going to pass that prop down, otherwise you would end up with a bunch of unknown props in your HTML, and also React would also complain about that with its unknown props warning. So this naive update on button would break our composition, because now the label prop wouldn't be passed to the inaccessible button with modal components anymore. This wouldn't happen with render props, for example. So what's your conclusion on this topic? Well, I'll share mine, but I invite you to think about it as well. I think component hooks are great for combining different behaviors within a component library. The library could export only components, but be composed on top of multiple component hooks. And that's exactly how Reakit is built internally. It also exports the component hooks, so you can use them in your component library as well. But it's important to be aware of the limitations of hooks. And render props are still very good for general use, especially when you don't need to deal with performance issues, which is honestly most of the cases. Most of the time, you don't need to optimize performance at the component level. And it's also good when you want to combine different components that might have conflicting props. And component injection, or the S prop, works very well for simple cases. For example, when components don't have custom props. It's also the best option, in my opinion, for when you are using React Memo. But you do need to take care of how you name your props. You can name them very specifically in a way that a collision would be very unlikely to happen, or when the outcome is very obvious. For example, you may have a dialog component that accepts a hide on-click outside prop. And if there is another component that accepts the same prop and you combine them, you will be probably fine because both components would probably do the same thing with that prop. Well, I'm not done yet. There is another thing I would like to talk about. And so the best way to fix our inaccessible button with modal component is by just using a button element instead of a div. This is the most effective way to fix this, and this is how you should be doing. So all the things that I'm talking about here would be unnecessary. But if we build this component in an open-close way, we have the possibility to render this component in different contexts. For example, Reakit has a menu item component that accepts both render props and the edge prop. And by the way, there is also a use menu item component hook. But we can combine it with our button with modal component, and it automatically becomes a menu item that opens a modal when you click on it, and focus the menu item after the modal is closed. Or there is another cool component that is currently in experimental phase, the combo box. And you could combine a combo box option with our component, and you would have a combo box with an option that opens a modal and moves focus back to the combo box after closing the modal. And this is really, really powerful because button with modal is an open-close component. It's completely agnostic about the context where it will be rendered. And that's why it can be turned into a combo box option or menu item, even though it doesn't know this component. You could imagine that button with modal is a component you import from library A, and the combo box option is a component you import from library B or from Reakit. And you can combine them without having to send PRs to the repository to modify their code and enhance their functionalities. And that's it. I hope you enjoyed. Thank you.
Yeah, thanks for the talk, Diego. I think it's really cool what you've done with Reakit. And I think we're going to check out the poll first. So we were asking about what kind of DOM element would you use when you need to generate clickable element, and majority answered a button, and some people answered a link. So what do you think of the results, or was this expected, or?
Yeah, I'm happy to see that. Actually, I've seen that question in the conference, and I think more than 30% of people answered div, which was impressive and sad at the same time. So I like to make the same question and compare the results. So the results here are different, but whether you use a button or div, or make some other mistake that you don't know that is making your component inaccessible, if you make it open for extension, like I showed in the presentation, you can solve it with Reakit or any other library that injects props into your component.
Yeah, so I guess we have smart audience in place or watching, and so let's say I wanted to learn about accessibility. What would be the how do I get started? Like, what's the first step?
So I think the best resource we have now is the YARA practice guide, which you can find if you search on Google by YARA practice, you'll find the site. It's currently in version 1.1, but there is a draft 1.2 version. You can also find on GitHub. And you'll find there some recommendations for building widgets like accordions, menu dialogues, many other widgets. And there's that's not a spec, it's just a set of recommendations. And it's also it shows the ideal scenario, like when screen readers support everything. So, for example, the dialogue there uses the ARIA modal attribute, which is not supported by some screen readers, but that's a good starting point.
Yeah, so it sounds like yeah, so they more or less specified that these different components will implement this and that. Is there an execute, like, can you execute it as a specification? Because it sounds like it's some kind of like technical definition. So is there something like test suite you could use based on the standards?
Well, I think you can use like some softwares like X, and there's packages for Jest and other, and also in the browser you can use the Chrome Dev tools to check. But the best way to check your site for accessibility is by learning how to use screen readers. Like on Mac, you have VoiceOver. You can activate by pressing Command F5. But I'm not sure if it's enabled by default. And on Windows, you have NVDA and JAWS, which are actually the most used screen readers. So the best way to check if your website is accessible for screen reader users is just by testing it with screen readers, just like you do with a browser for sighted users.
Yeah, I mean, there's this terminal-based browser called Lynx. It's really fun to use Lynx and go to some popular site and see what it looks like when it's rendered text. So that's sort of, I guess the point it will be to try different tools or different ways to render the site or experience the site. So based on, I mean, I saw Reakit the first time 1 year ago in June or so, and it looks like it came along a long way. So I think you improved the API a lot. So what's your plan for Reakit? What's going to happen next with the toolkit?
Sure. So I'm actually like improving it in several ways, like performance-wise. This year, I've been doing a lot of performance tests. Like most developers should not worry too much about this, but if you work on a component library that will be used in several projects in many different ways, you probably want to test some extreme scenarios. So I've been doing this a lot this year, and yeah. So the next version will include a different way of doing state management, which is highly inspired by Recoil. And also the API will improve a lot in a way that currently you have to pass state prop to all components, and in the future you will whether or not need to use the state prop or just pass the state prop to the container component.
Sounds really, really cool. I mean, years ago, I wrote a headless table library for React. It was headless before people knew what's headless. But what I learned from the project was that it really makes sense to separate the state and styling and the components and logic. So when you achieve this well, you can build anything with the toolkit. So I have a question from the audience, and it goes so that how do you verify and test the accessibility of Reakit? So what do we have in place for testing?
Okay, so there is a Reakit test tools package, and there's a lot of helpers that are built on top of React testing library, and we use that in our integration tests to test like if the focus management is being done right. So yeah, we have like only for the dialogue component, we have a test file with more than 1,000 lines, and we have that for all the components. And we also do a lot of browser testing with screen readers on Mac and Windows as well.
Yeah, that sounds really, really cool. But I guess the point is that if you use, I guess the way you use Reakit is that you have your own component library, or you know that I want this descended component, but at the same time, I don't want to write everything myself. So I guess the way I would use Reakit is that I will, let's say I have my own button, and I will use the button from Reakit, or I will do my dropdown, but I will use your primitives to develop the dropdown. Is this correct? Or how do you use Reakit in practice?
Yeah, so you can use this as a base for your own components. It comes totally unstyled, so you're free to add styles to it. And you can also combine your own components with Reakit components if you build your components like I showed in the presentation, open for extension. So your components don't need to be aware of Reakit. You can just combine them if you want.
Okay, that sounds really cool. I think we're out of time. So again, thanks for your talk and the great session. So.